Imagine structures built thousands of years ago, so advanced they defy everything we thought we knew about ancient civilizations. For centuries, history books have painted a picture of early humans as simple, struggling to survive. But what if that picture is missing crucial pieces? What if ancient people possessed knowledge and technology that modern science is only now beginning to grasp? Today, we're diving deep into 7 astonishing ancient structures that rewrite the rules of history, leaving us to wonder, who really built these marvels and how? Our journey begins in southeastern Turkey, in a place that has completely upended our understanding of how civilization started. Here lies Göbekli Tepe, a site that makes Stonehenge look like a recent construction. Discovered in 1994, this place dates back an astonishing 11,600 years, predating the invention of writing, pottery, and even the wheel. For context, this is more than 6,000 years before the first pyramids of Egypt. What makes Göbekli Tepe truly baffling is its sheer scale and sophistication. We're talking about massive, intricately carved T-shaped pillars, some weighing up to 20 tons, arranged in monumental circular enclosures. These aren't just random rocks, they're adorned with detailed carvings of animals, wild boars, foxes, lions, birds, and snakes that seem to leap off the stone, full of dynamic life. The real head-scratcher here is who built it. Archaeological theory has long held that complex societies and monumental architecture only emerged after the development of settled agriculture. The idea was simple. Farming led to food surpluses, which allowed people to specialize, leading to communities, then cities, and eventually grand constructions. But Göbekli Tepe was built by hunter-gatherers. That's right, people who roamed the land, hunting animals and foraging for plants, somehow organized themselves to quarry, transport, and intricately carve these enormous stones. This required an unprecedented level of social organization, planning, and specialized labor that simply wasn't supposed to exist among hunter-gatherer groups. How did they coordinate thousands of people for such a monumental task without the traditional incentives of a settled agricultural society? It's like finding a supercomputer in a caveman's toolkit. The very existence of Göbekli Tepe forces us to reconsider the entire timeline of human development. It suggests that perhaps the desire to build something sacred, something awe-inspiring, might have actually preceded the development of agriculture, possibly even inspiring it. It's a place that whispers secrets of a past far more complex than we ever imagined. Next, we travel to the scorching sands of Egypt to witness an achievement so monumental, so precise, it continues to mystify engineers and historians alike: the Pyramids of Giza. While iconic, their construction remains one of humanity's greatest unsolved puzzles. The Great Pyramid of Giza, in particular, built for Pharaoh Khufu, stands as a testament to an almost inconceivable level of ancient engineering. It consists of an estimated 2.3 million stone blocks, each weighing between 2.5 and 15 tons, some even heavier, sourced from quarries miles away. The core problem isn't just moving these colossal stones, but placing them with staggering accuracy. The pyramid's base is nearly a perfect square, its sides aligned almost precisely with the 4 cardinal directions: north, south, east, west, an accuracy that rivals modern compasses. the angles of its slopes are so consistent, varying by only a fraction of a degree. Inside, the Grand Gallery and various chambers showcase a mastery of dry masonry where stones fit so tightly you can't even slip a credit card between them. How did the ancient Egyptians, using only copper tools, ropes, and sledges, achieve such architectural and astronomical precision? Theories range from massive ramps, which would have been larger than the pyramid itself, to sophisticated lever systems, or even the use of water locks, but none fully explain the sheer scale and consistency of the work. The precision with which the pyramids of Giza were built, their incredible alignment with celestial bodies, and the sheer effort involved suggest a level of scientific and engineering understanding that appears thousands of years ahead of its time. It's as if they possessed a secret blueprint for monumental construction that we're still trying to decipher today. From the desert, we journey to the green plains of Wiltshire, England, where the iconic stone circle of Stonehenge has stood for millennia. Dating back to around 3000–2000 BC, this prehistoric monument isn't just a collection of big rocks. It's a monumental feat of engineering, astronomy, and community organization. The sheer challenge of its construction is mind-boggling. Some of the massive sarsen stones, weighing up to 50 tons, were transported from Marlborough Downs, about 20 miles away. Even more mysterious are the blue stones, weighing up to 4 tons each, which were brought from the Preseli Hills in Wales, a journey of over 140 miles. How did Neolithic people, without the wheel or advanced machinery, manage to quarry, transport, and then erect these enormous stones, some forming lintels placed atop vertical pillars? But the true genius of Stonehenge lies in its purpose. It's not just an impressive construction. It's a giant, meticulously calibrated astronomical instrument. Its layout is precisely aligned with the solstices and equinoxes. On the summer solstice, the sun rises directly over the heel stone, its rays piercing through the monument's central axis. On the winter solstice, the sun sets to the main entrance. This incredible alignment points to a sophisticated understanding of celestial mechanics and the cycles of the sun and moon. It was likely used as a calendar, a place for rituals tied to the changing seasons, and perhaps even to predict astronomical events. The builders of Stonehenge possessed a level of astronomical knowledge and an ability to translate that knowledge into a massive, permanent structure that speaks volumes about their intelligence. They weren't just observing the sky, they were building a monument to capture its rhythms, demonstrating an advanced grasp of time and space centuries before geometry and trigonometry were formally codified. Our next stop takes us beneath the waves of the Aegean Sea, off the coast of the Greek island of Antikythera. In 1901, sponge divers stumbled upon an ancient Roman shipwreck, and among its treasures, they found something that redefined our understanding of ancient technology: the Antikythera mechanism. At first glance, it looked like a corroded lump of bronze and wood. But careful cleaning and, later, X-ray tomography revealed an intricate gear-driven device of unparalleled complexity. This wasn't just a simple clock or astrolabe. It was a mechanical computer built around 150–100 BC. The purpose of the Antikythera mechanism was astonishing. It could predict astronomical positions and eclipses for decades in advance. It tracked the cycles of the moon and sun, the movements of at least 5 planets known at the time: Mercury, Venus, Mars, Jupiter, and Saturn, and even displayed the timing of major athletic games like the Olympics. With over 30 precisely cut bronze gears, some interlocking with remarkable accuracy, it calculated complex astronomical phenomena. The precision of its gearwork and the sophistication of its design are mind-boggling. Historians and scientists initially struggled to believe such a device could exist in ancient times. Nothing remotely similar has been found from that era, or for the next 1,000 years. It suggests a forgotten tradition of engineering excellence, a peak of technological understanding that vanished from the historical record. Was it a one-off genius invention, or a surviving example of a lost ancient technology that far surpassed what we thought the Greeks were capable of? The Antikythera mechanism is a stark reminder that our historical narratives often have huge, unexplained gaps. Now, let's journey across the vast Pacific Ocean to the remote island of Pohnpei in Micronesia. Here, rising eerily from a shallow lagoon, is Nan Madol, often called the Venice of the Pacific. This incredible city, built between 1200 and 1500 AD, consists of 92 artificial islands constructed from massive basalt columns, forming a network of canals and stone walls. The scale of the construction is immense. The building material consists of enormous hexagonal basalt logs, some weighing up to 50 tons, measuring up to 25 feet long. These columns were quarried from a site on the other side of Pohnpei Island, then transported by unknown means and meticulously stacked without any mortar to form walls towering up to 25 feet high. The immediate problem is obvious. How did the ancient people of Pohnpei, without modern machinery, lift, transport across water, and precisely stack these immense stone columns? The logistical challenges are staggering. Local legends speak of powerful sorcerers using magic to make the stones fly, or of a giant eel that assisted in the construction. While these are myths, they highlight the true mystery. There's no archaeological evidence of the tools or techniques that could have achieved such a feat. It's not just about moving one or two stones. It's about building an entire city out of them, constructing artificial islands on a coral reef in a challenging marine environment. Nan Madol represents a level of engineering prowess and organized labor that defies our understanding of what was possible for island societies of that era. It's a silent stone city, standing as a monument to forgotten knowledge and unimaginable effort. Our next marvel transports us to the heart of Mexico, to the ruins of Teotihuacan, the city of the gods. This ancient metropolis, whose builders remain largely unknown, was established around 100 BC and flourished for centuries before its mysterious collapse around 600 AD. At its peak, it was one of the largest cities in the world, with a population possibly exceeding 125,000 people. What makes Teotihuacan so extraordinary is its incredibly precise and sophisticated urban planning. The city is laid out on a meticulous grid plan, oriented with incredible accuracy. Its main thoroughfare, the Avenue of the Dead, runs perfectly north-south, flanked by monumental pyramids and ceremonial platforms. The two most prominent structures, the Pyramid of the Sun and the Pyramid of the Moon, are colossal. The Pyramid of the Sun, one of the largest pyramids in the world, is aligned to significant astronomical events like the summer solstice. The entire city's layout appears to be a giant cosmic calendar or map, reflecting a deep understanding of astronomy, mathematics, and urban design. The problem here is multifaceted. Who were the Teotihuacanos? They left no written records, and their language is unknown. How did they achieve such complex urban planning, constructing entire districts with drainage systems, apartment compounds, and intricate murals, all without modern surveying tools? The city's alignment and the precision of its structures reflect an advanced scientific understanding that feels far too sophisticated for its time. When the city was eventually abandoned, its name and builders were lost to history, leaving behind a ghost city that stands as a testament to an unknown, highly advanced civilization. Finally, we travel high into the Andes Mountains of Peru, overlooking the ancient Inca capital of Cusco, to behold Sacsayhuamán, pronounced Sacsayhuamán. This colossal complex, often described as a fortress, showcases an engineering marvel that continues to stump experts. Built by the Inca, starting in the 15th century, Sacsayhuamán consists of massive, interlocking stone walls. What sets it apart is not just the size of the stones, some weighing up to 200 tons, but the incredible precision with which they are cut and fitted. These stones are not uniform blocks. They are irregular polygons with convex and concave surfaces fitting together like a giant impenetrable jigsaw puzzle. There's no mortar holding them together, yet they are so tightly joined that you can't even slide a knife blade between them. The challenge is immense. How did the Inca, who didn't have iron tools, the wheel or beasts of burden capable of moving such massive weights, manage to quarry, transport, and meticulously shape these colossal stones? The level of craftsmanship required to achieve such tight, intricate joins on stones of this size, some with 12 precisely cut angles, is almost unbelievable. This dry stonemasonry technique not only made the walls incredibly strong, but also remarkably earthquake-resistant, a crucial feature in a seismically active region. Sacsayhuamán is a masterclass in engineering and stonemasonry, demonstrating a level of skill and precision that far exceeds what we typically attribute to civilizations of that era. It makes us wonder what other secrets the Inca and their predecessors possessed, secrets that allowed them to manipulate stone with such incredible artistry and strength. These 7 structures, scattered across the globe, are more than just ancient ruins. They are bold questions etched into the very landscape of our planet, forcing us to reevaluate what we think we know about history, technology, and the capabilities of our distant ancestors. They highlight the possibility of lost knowledge, advanced skills, and perhaps even different understandings of the world that have been forgotten over time. They are testaments to human ingenuity, pushing the boundaries of what was supposedly possible, and inviting us to look deeper, to question more, and to embrace the thrilling mysteries that still lie hidden in our past. If these ancient enigmas left you wanting more, then click on this video next for another journey into the unknown.